We'll proceed in flux calculation in calculus. Flux is calculated as surface integral. Flux is calculated as surface integral. So, surface integral is nothing but the vector field integration along a surface. If I have a vector field is a vector field is a vector which has a vector field is a vector which has its components as algebra. So vector field is a vector which has components as algebra. If that is the case, if that is the case, then if I have a vector field x plus yi plus x plus sine yj, x plus yi plus x plus sine yj. If this is the vector field, then what is its integration along xy plane? Then area vector is xy plane. What is flux? Flux is vector field capital F dot dA vector. Surface integral is called flux. If I have a vector field, then what is its surface integral? What is integration of a vector field along a particular surface? What is integration of a vector field along a particular surface? So, if I am doing integration of a algebra x square plus y square along the xy plane, it is x square plus y square dx dy, where the xy plane has direction as k vector. Then, if I talk in term of flux, flux is surface integral. Vector field, capital F is the vector field, algebraic vector, capital F dot dA vector, capital F vector dot dA vector. Okay, so capital F vector dot dA vector. So capital F vector is algebraic vector, and then dA a area is a area which has a direction. So if I am saying I am doing integration of x square plus y square, if I am doing integration of x square plus y square against xy plane, then implicitly the vector field is x square plus y square k, then dot d dxy plane, and its direction is k. K dot product would go away, and then it will be x square plus y square dx dy. So this is surface integral. Surface integral, if I say I am doing three-dimensional integration, then this is one special case of surface integration, where I have a vector field, I have a surface, and surface has a direction. So if I am saying x square plus y square dx dy, then actually we are saying x square plus y square k dot d area vector dx dy k. So k and k gone, and x square plus y square dx dy. So the three-dimensional integration is nothing but two-dimensional integration is nothing but the special two-dimensional integration is nothing but the special case of the surface integral or flux. Amazing, right? If I have a flux and if I have a vector field capital F, and then if I have an area capital F dot dA vector is the net integration. If the area vector is xy plane, then the kth component of flux vector field would come into the picture. This is what generally, knowingly, unknowingly, we do. X square plus y square dx dy. It is actually x square plus y square k, and then dx dy k. Anyway, we have calculated the flux, and flux is nothing but we have calculated the flux. Flux is nothing but a vector field that is passing through a surface area, a vector field that is passing through a surface. Okay, a vector field that is passing through a surface. If this is a liquid, and vector field is velocity vector field, then what is the volume that is coming out of the surface? That is flux. Now, the idea is flux density. Flux density is coming into the picture in a way that if I have, having a surface, instead of having a surface, consider a volume. Instead of just a surface, consider a volume. Volume is a surface only, right? It is a closed surface. If I have a volume, there was a kind of there was a flat plastic, plastic, and someone molded it into like this. Now it is a full cylindrical surface. If that is the case and there is a vector field, then how much is the volume of the liquid that is passing out through this surface? Means vector field is entering. If it is liquid, then liquid is entering into this surface, and from here it is coming out. Then what is the volume of the liquid that is coming out of this surface divided by the volume of this material? That is called flux density. So surface integral is flux. Surface integral is flux. Surface integral is flux. Then flux divided by the surface volume, considering surface is a closed surface. Closed surface means it make a closed volume. This is open surface, this is open surface, open surface, open surface, open surface. Now it is fully closed surface. It is closed from everywhere. If that is the case, then flux of full surface, this surface, this surface, this surface. If I add surface integration, then it is flux divided by volume of this entity. That is flux density. Now question is arising. Now we have talked about many story in the flux density. Flux through a closed surface divided by the volume is the flux density. This is called geometric way of calculating the flux density. Flux density is nothing but divergence. It is also called divergence. So if I have a vector field, then it divergence. If vector field is coming from outside, vector field is coming from outside, and it does not have any variation as far as we see along the x-axis. Consider this is x-axis. Consider this is x-axis. If this is x-axis, then flux is coming along the x-axis and it is passing the surface. Consider flux is 2I. If it is 2I, then there is a constant flux that is coming, like a liquid whose velocity is 10 meter per second. If velocity is x meter per second, then as we move, the velocity of the liquid is increasing. If that is the case, then the liquid that is hitting this surface and liquid that is hitting this surface, the velocity is different. If it is xi, if that is the case, then the liquid that is passing through this surface and liquid that is passing through this surface, even though their surface area is same, okay, still the flux of this region is less, flux of this region is more. If liquid coming entering into this volume region, consider this is, if this is velocity is coming in this x-axis, consider this full surface is in yz plane. The area vector of this surface is in yz plane. If that is the case, if area vector of this surface is yz plane, then flux calculation will happen for this surface and this surface only. Consider both surfaces are same, means their area is same. Now the velocity vector is xi. If that is the case and this is x-axis, consider this is origin. If this is origin, then this is x-axis. If that is the case, then velocity vector would hit this surface, okay, and then it will hit this surface has the normal along this direction, and this surface has not as area vector along this direction. Now this side, the divergence will be, if I calculate the surface integral, it would be negative. This side it would be positive. This side it is negative, this side it is positive. If I add these two, and if the it is xi is the velocity vector, then this would be less, it would be high. So net flux would be positive. Divided by this volume, divergence is positive. But consider that liquid velocity is 2I. Liquid velocity is 2I instead of xi. If it is 2I instead of xi, then it will be, here the surface integral and this surface integral would be same. One would be negative, and cutting these two will be 0. So flux will be 0, flux density will be 0, divergence will be 0. What is divergence that we have talked? If someone is telling that liquid is crossing here at 10 meter cube per second, and here it is coming out as 50 meter cube per second. Just I am telling a question of IQ level. If I have two surface, if I have a two surface, from one surface liquid is entering at 10 meter per second, 10 meter cube per second, and there is another surface liquid is coming out at 100 meter cube per second. What anyone would say? If I have two surface and liquid is coming from here 10 meter per second, and liquid is coming out here 100 meter cube per second, entering here at 10 meter cube per second, then what someone would take the inference? This proves that there is some liquid generation tool inside the, in between the surface, which is producing 90 meter cube per second of the liquid. That is the rate, because 10 meter is entering, 100 10 meter cube per second is entering, and 100 meter cube per second is exiting. This proves that inside it there is a liquid producing, one entity is there which is producing the liquid, which is producing the liquid at 90 meter cube per second. That's why it is adding there. Divergence is nothing but, if there is the vector field is coming from outside, right? 10 meter cube per second means it is coming from outside. This, then the vector field source is outside. What about the vector field source is inside the volume? This is called divergence. Divergence means, divergence, this this fundamental, probably it would not be available anywhere else. This is our way of talking about the divergence. This may not be available everywhere. If that is the scenario, if that is the scenario, that means this is the scenario, then if I prove that the vector field source is available inside the volume, then vector field has divergence as far as this volume is concerned, where the motor is placed, which is generating the liquid. So divergence is nothing but the flux along the surface of a item divided by volume of the item. This talks about the divergence of a vector field in this volume, where volume tends to 0. If that is the case, then flux. So if I am taking this surface, if I am taking this surface, if I am taking this surface is, one is like this, second surface is circular, and third surface is again circular. This is a cylinder. If I am taking a cylinder, then surface integral is this surface integral of the vector field, this surface integral, and this surface integral. If I add all three, divide by the volume, where volume tends to 0. If that is the case, then this volume would reduce small, and it will become a point. That point, what is the divergence at that point? If that is the case, then the surface integral of that point divided by the volume of that point. So this is called geometric way of calculating the divergence. Geometric way of calculating the divergence. If that is the case, then it is kind of surface integral divided by the volume. If it is positive, then conceptual, okay, in a kind of in a in a hypothetical way, if if the kind of vector field is xi, the example I am giving, the vector field is xi, then hypothetically it looks like the the vector field generating engine is inside the volume. That's why its divergence is not zero. Divergence free vector field whose divergence is zero. If that is the case, then it is divergence free. One way of calculating divergence is surface integral divided by the volume. Other way of calculating the divergence, surface integral divided by the volume. Other way is if someone has vector field capital F and its component is F1, F2, F3, means F1i plus F2i plus F3j, F1i plus F2j plus F3k, where F1, F2, F3 are in capital and capital F is the vector field. Then dF1 by dx plus dF2 by dy plus dF3 by dz, dF1 by dx plus dF2 by dy plus dF3 by dz. Whatever it comes, that is the divergence of this vector field. Means how much the F1 component is changing if I go along x-axis, how F2 component is changing if I go along y-axis, how F3 component is changing if I go along z-axis. If that is the case, then then z-axis. If that is the case, if add all three, it becomes divergence of a vector field. If it is xi, then divergence is 1. If it is xi, then divergence is 1. dF1 by dx is 1, other 0. Now, can I prove this? What we are getting? This what I talk dF1 by dx plus dF2 by dy plus dF3 by dz, then it is divergence is not dependent upon the surface at all. It is only dependent upon the vector field. If that is the case, the divergence is only dependent upon the vector field. If divergence is only dependent upon the vector field, then it should the item what we are taking, it should be it should be item independent. Can I prove it really? It is item independent, position independent if it is df1 by dx plus df2 by dy plus df3 by dz. This is a scalar quantity it is giving. There is nothing called it is calculated over a cylinder, it is calculated over a sphere, it is calculated over a cube, whatever it is. Divergence is only divergence only show the importance of the vector field. How is the vector field? If vector field is altogether constant, 2i plus 3j plus 4k, then its divergence is 0. Divergence is 0 means same vector is applied hitting all the surfaces. Then net and all the surface, typically they cancel each other. This area vector is along this direction, then this area vector is along this direction. They cancel each other. If half of this is like this, then next half is downward. They cancel each other. If that is the case, then capital F dot dA vector all along the surface is 0. So 0 means, but if there is a df1 by dx, df2 by dy, df3 by dz, then there will be divergence. But still, df1 by dx, df2 by dy, and df3 by dz, if I add these three, df1 by dx, df2 by dy, and df3 by dz, if I add these three, it should not become 0 because it is differentiation and it can be negative. Like df1 by dx is positive, then df2 by dy is negative, like x minus y. x minus y is a vector field, even though df1 by dx is not 0, df1 by dy is not 0, but still the divergence is 0. So now question arises is, can I prove the divergence is shape independent and position independent? Divergence is shape independent and position independent. So that is the question. So that we should see that it is really position independent, and means this is what the scenario is. Now consider that I am trying to calculate divergence of a, this will take long session. Probably we will do in other video because this is a big thing. Divergence calculation of a vector field is position independent and shape independent. Let's try shape independent. Consider I have a vector field that is xi. Vector field is xi. If it is xi, then what is its divergence calculation? If I take a cube that is centered at the origin, I am trying to calculate divergence at the origin. Divergence is calculated at a certain point, because consider that vector field is sin x plus sin y. Then divergence is cos x plus cos y. Now I have to place x value and y value. So divergence itself is an algebraic equation. If f1, f2, f3 vector field for vector field are algebraic, then their divergence itself is f1, f2, f3. Then their divergence itself is algebraic equation. If that is the case, divergence itself is algebraic equation. Then algebraic equation would change as per the coordinate. Algebraic equation would change as per the coordinate. If now, so divergence at what point? So divergence at origin, we are trying to calculate for a vector field. If vector field divergence come as a numeric value where there is no x, y, z, then it does not matter. Like xi, if xi is the vector field, then its divergence is 1. Now doesn't matter you calculate at origin, so divergence is position independent in this way. But divergence is always shape independent. Divergence is position independent in a way when it comes as scalar. So I was talking about position independent and shape independent. Divergence is always shape independent because there is no calculation for the shape in the divergence. But it is position independent net quantity if the net divergence that is calculated is a scalar value, numeric value, not algebraic equation, whatever it is. Let's first try divergence is shape independent. I have xi, and let's calculate its divergence for a cube. Cube is, now let's calculate at origin, but it is shape independent. It is position independent. That we will see. Now let's calculate. Now I'm trying to prove it is shape independent. Let's calculate at the origin. Now at the origin, if I take a cube which has length, width, height all 1, then what is its divergence? What is the equation of the vector field xi? And then what is the equation as far as kind of if I trying to calculate the divergence, then if I take a cube, then only this side, if this is x-axis, then this side will show the flux. Otherwise this side and upside, they are parallel to this vector. If that is the case, only this side and this side should show the flux. If I take this side, then its distance is half from the origin, half, and then dx, dy, dz. Area vector is dy, dz along I direction. Dy, dz, I, xi. So x, dy, dz. Now x is constant because dy, dz, x I can keep outside. Dy, dz minus half to half, minus half to half, 1. 1 into x. X is half, half. Half is the vector, half is the flux of this side. This is a cube. Now this side again xi dot dy dz minus I, because in this side the surface, if I take a cube like this side, and this side, if this is a cube, for this side that is on minus x-axis, the area vector is like this. So dy dz minus I. If it is dy dz minus I, then xi dot dy dz minus I, it will become minus x. Minus x I can keep outside. Again, integration is 1. So minus x means minus half. Minus x means minus half. I mean, there is something wrong. So now it is xi, this side also. Okay, minus xi. So minus x is the next integration. dy dz comes to 1, minus x. X is minus half. So minus minus plus. So half plus half. So net the net flux for a cube, unit cube is 1, divided by volume of unit cube is 1. So net divergence is 1. Xi, if I go, this is called geometric way. Net flux divided by the volume. So if I go with the algebraic way, then it is df1 by dx, df2 by dy, df3 by dz. Then it comes as 1. So 1 and 1, it is matching. But we are trying to prove it is shape independent. It is shape independent. Let's take a sphere. Let's take a sphere centered at the origin. Now I have smooth dA vector everywhere. I don't need to take surfaces. So the dA vector of a sphere, what it is? Now if I take in Cartesian coordinate system, then we can do like minus dz by dx, minus dz by dy, minus dz by dx I vector, minus dz by dy j vector plus k, and then d xy plane. This is the Cartesian coordinate way of calculating vector cross product. Please watch previous video. So this is the way to calculate the area vector. So area vector in Cartesian coordinate is minus dz by dxi minus dz by dyj plus k, and then dxy plane, dx dy. Okay, and then dot product with the vector field. So xi dot minus dz by dxi will remain, other will go off. So x minus x into dz by dx dy integration minus. Now consider this is a sphere of the radius a, not unit sphere, because we are trying to say divergence is not dependent upon the size shape. Either it is cube, it is a sphere of any size. If that is the case, of any size, if that is the case, then now minus dz by dx, z, x square plus y square plus z square equal to a square is the equation of a sphere. Then z equal to a square minus x square minus y square root. Z equal to square root of a square minus x square minus y square. Now I can say dz by dx is nothing but minus x divided by square root of a square minus x square minus y square, minus x, and here I have again minus x. So minus minus gone, it is x square now. X square divided by square root of a square minus x square minus y square. So I have to calculate integration of x square, okay, x, and here x square divided by a square minus x square minus y square dx dy. Okay, it looks little tedious. Now let's consider x equal to a square root of a square minus y square cos theta, polar coordinate. Then dx equal to square root of a square minus y square constant minus sine theta d theta. If that is the case, then x square would become a square minus y square cos square theta divided by square root of a square minus y square minus x square would become a square minus y square cos square theta. Square root of a square minus y square would come out. 1 minus square root of 1 minus cos square theta will turn into sine theta. So top, it is a square minus y square. Top is a square minus y square divided by a square minus y square divided by square root of a square minus y square sine theta. And there it is square root of a square minus y square minus sine theta d theta. So sine gone, square root gone, only minus remained there. So minus I can keep outside, a square minus y square I can keep outside. Now it is only d theta. Integration of d theta is theta. Now if it is a sphere, then x is minus a to a. If it is polar coordinate, minus a is pi angle to 0. So theta is pi to 0. Then it will be minus pi. Minus cancelled, and it is now pi. I am missing something. Okay, it is, I started with integration of 1 by d x square divided by square root of a square minus y square minus x square dx. Okay, x equal to square root of a square minus y square cos theta. The numerator become a square minus y square cos square theta divided by square root of a square minus y square come out, and then a square root of 1 minus cos square theta, that is sine theta. And there dx become minus square root of a square minus y square sine theta d theta. Sine gone, the square root gone, minus, and here a square minus y square. So minus, and in bracket a square minus y square came out, cos square theta d theta, that is the integration. So what is integration of cos square theta? That is theta by 2 plus sine 2 theta by 4, pi to 0. So whatever sine 2 theta factor is gone, pi or 0. So theta by 2, pi to 0. Then it will become pi by 2. Instead of pi, now it is pi by 2. So pi by 2 minus pi by 2. So minus gone, pi by 2. Pi by 2 I can keep outside, and it is a square minus y square with dy. So a square y minus y to the power 3 by 3. Okay, a square minus y square integration, if I take, then it will be a square y minus 8y to the power 3 by 3. Okay, if I place minus a to a, if I place a, then it is a to the power 3 minus a to the power 3 by 3. Then it becomes 2 a to the power 3 by 3. Okay, if that is the case, then it would double it, minus a to a. 4 a to the power 3, 4 a to the power 3 by 3. I believe that would be the integration. 4 4 a to the power 3 by 3. Outside, outside, outside I have, outside I have pi by 2. So pi, 4 pi a to the power 3 by 6. It will resolve in 2, 2 pi a to the power 3 by 3. 2 pi a to the power 3 by 3. Now when I am taking Cartesian coordinate, xy plane in x and y, then we are trying to calculate for the upper half. We try to calculate only in the upper half, not the down part. Okay, I did not take a spherical coordinate system. If that is the case, then I have to multiply it by 2. So if that is the case, then it becomes 4 pi a to the power 3 by 3. That is the net flux. 4 pi a to the power 3 by 3. Now divided by the volume. Volume of a sphere is again 4 pi a to the power 3 by 3. If that is the case, then again the divergence is 1. So either you take a sphere of any radius, q of any size, I take took 1, then still the divergence is 1, 1. So this proves that divergence is only dependent upon the vector field. If vector field divergence, if I calculate through this, I took geometric way. If I took geometric way. If I take algebraic way, then df1 by dx, that is anyway 1. So now I took cube and sphere, if I take cylinder also around this origin, then I was trying to calculate at the origin, but it doesn't matter because df1 by dx is numeric 1. If it is comes in algebra, then I have to say I want to calculate at this point, this point, this point, this point. Otherwise, it is position independent. But anyway, it is shape independent. We saw. We will see shape independent for the other shape, other vector field also. I'll try a vector field R vector. R vector is nothing but xi plus yj plus zk. Now we did for xi1, xi plus yj plus zk. For that also we will try, and then we will see that it is position independent. Position independent in the sense that I take any position, still the divergence would be same. Means it will be dependent upon the kind of the algebraic equation. So if I manage to have the divergence and numeric one, not algebraic equation, then it is position independent also. So that we will see.